All right, here's a great example of a table that is given in which we're going to create a system of equations, but using technology and matrices and a matrix solver um, to make this as simple as it can be. So there's a couple tricks in this one, but overall, I think setting up the system, even without like knowing everything about the data, I think it's pretty clear. So let's take a look here. We have two countries and some data was collected, US and Europe, and then um, we don't know for the purpose of this problem the variables, right? X represents um, how many smoked cigarettes in this US study, and then how many were cigarette free would be represented by Y. So the first question is asking us to create a linear system of four equations and four unknowns. Okay, just like what is a system? Well, the total, this 12,000 here, and I know I have answers already given. That's okay. There's a lot to this video, and I just took some screenshots. So the total of the US in the study is the 12,000. So whether they smoked or not, right, X plus Y is represented by 12,000. So all four of these um, choices so far look good, but really, like this data yields us this information, okay? And then similarly, we could say, well, for Europe, right, we have, let me just change colors here, Z plus W equals 96,000. All right. Um, what else do we know? Well, we do not know the results of this column, right? The total that smokes cigarettes, X plus Z, is unknown. X plus Z, so I'm just going to write that to the side, is unknown. And again, that represented the total in the study who smoked cigarettes. Well, we could probably kind of manipulate some things and figure that out, right? But for the purpose of this, we will pretend we don't know. All right. Again, it's wanting us to set up the system based on the table. All right, moving forward. Y plus W, we know. We do know this column, right? The Y plus W, running out of color choices here. Well, I could change it. It'll be fine. Y plus W is 70,210. So those were the totals of cigarette-free in the study, right? The number of cigarette-free in US is Y, the cigarette-free in Europe is W, and total we get that 7210. The last thing we know for sure is that all of these combined is going to give us the 108,000. X plus Y plus Z equals 1. Oh, plus W. I forgot a variable there. Plus W, there were 4, equals 108,000. Okay, and that's why this first choice fits the bill. Right, there are our systems. Does it have a unique solution? So I know it is answered, it has infinitely many, but why? So I went to this site. There, okay, you could do this in Excel. You could do this using a TI calculator. We're just inputting matrices and solving them in what we call a reduced row echelon form. So there are tutorials out there. I just took screenshots. The main point of this is like how to finish this problem, not necessarily how to solve a matrix, but RREF in your TI calculator. Again, Excel, you could do it. This website, I shared in another video, but let me go ahead and write it one more time. GeoGebra. .org/m/p8xp 32kz. Very random. But anyways, we can input matrices and do different things with them. So different buttons will show up depending where you're at. So I already input it, and then if you need to change anything, you could hit Alter here. This often goes to exact values. If you prefer decimals, if you use them, you could change that. You could do different operations here, but really, for systems, we want this. Okay, once you click that, it yielded this matrix here. So what does that mean? It took our data and tried to break it down as far as it could to solve for x, y, z, and w. Unfortunately, with this one, this row of zeros usually tells us there's an infinitely many solutions. So why is that? Well, because the furthest it could reduce is telling me this new set of systems, which is better than the original, but it's still, we're going to have variables dependent on each other. So why do I say that? What does that mean? Well, let's think about what it produced here. Remember, this column is represented by the x, y, z, w. So this says x minus a w equals a negative 58 to 10. Okay, the next row here says y plus w equals 70,000 to 10. And last we have z plus w equals 96,000. Notice all three of these still have a w. So what we can say is like, well, if you told me one thing, if you told me w, I could get all the rest, right? I mean, suppose w, we'd have to pick something that makes sense here, was like, I don't know, 60,000. Okay, if I knew for sure w was 60,000, then I could plug it in and get all the rest. So z, I could see, is minus 60, 36,000. Here I could see y is 10,000 to 10. And here I'd add 60 and x would be, about 1,800, just rounding. But it's dependent, right? All these others are dependent on what w is. Or likewise, if I knew any of them, x, y, or z, or w, right? I could then find w, say I knew z. We'll pretend this example, right, what we just did. Say z was 36,000. Then I could solve for w, which we knew is 60, and then I could go back and substitute and find x and y. Okay, so all of these are dependent on, like, I need a bit more information. With what was given, there are infinitely many solutions here. Okay. Now, being that it's whole numbers, it's not quite infinitely, but because we can't have partial humans, but that's okay. We say there are infinitely many solutions. All right, next, what does this indicate about the missing data? It's insufficient, right? Because I can't find x, y, z, and w. If I knew something more, yes, but with what is given, I cannot. Alrighty, so then they throw in, so you go through that, and this last question B here. What if I did give you something else? What if I told you that there were 34,510 more European 10th graders smoke cigarettes, then the US 10th graders find the missing data. All right, let's go back up and look. What does that mean? All right, so remember X is the number of US smokers in this survey. I'm just going to leave it at that. And Z was the number of European smokers. So if there were 34,510 more, that would mean I would need to add 34,510 to the X in order to get Z, right? Or equivalently, because there's more than one way to do this, I could say X equals Z minus 34,510, right? Or, like I said, many ways to write it. Or Z equals, or I'm sorry, Z minus X, I was going to say, equals 34,510. All right, however you want to do it. Point being, I want it in a matrix form, right? So I'm kind of thinking like this form. But if I were to add to this matrix, it's going to be another row, and X would be a -1, Y is irrelevant here, Z is 1, W is 0, and I know that we get 34,510. Often with these matrices, like when we write all these numbers, this equal, we do a little dashed here. Okay. But anyways, we have all the other matrix, right? But we need to add this fifth row. All right. So again, I took a screenshot, but I wanted to explain what was going on in the process. So we come down here. Notice I added a 6th column as well. GeoGebra and their matrix solver they have here, in order to get reduced row echelon form, you have to have a square matrix on the left. Okay, you have to have a square matrix. So what do I mean? If I have 5 rows, I need 5 columns. So you could kind of cheat that by just, all right, I don't have a new variable, what we use X, Y, Z, W, like V or T or whatever. I don't have a 5th variable. So if I just make them all 0, it will allow the computer program to still go through the steps needed to solve this matrix. Oh, and I'm actually pointing at the reduced row echelon form, right? Notice we have this diagonal of 1s. When you get that, there's one solution, and that is called the reduced row echelon form. So really, I should have been talking about this with the 5 rows, 5 columns, even though the 5th column is irrelevant. Okay? So remember above we had said, writing in matrix form, we had -x plus 1z equals the 34,510. So that I kept everything else the same. I had to adjust this last column, like to move it there, right? And then to add these zeros in here. But then when I click on that reduced row echelon form, it gave me what was below. So notice here that I said 5 columns, but 5 columns of variables. Really, we have 6 columns, right? And 5 rows. That's always true when you're getting in this form of reduced row echelon form. So now we have X, right? This is X, this is Y, this is Z, this was W. So we could finish answering that now that they gave us that additional information, and that's what I have typed in here. It's a video. You can pause, rewind, fast forward, right? Because I know I can't fit it all on one screen. Unfortunately, as well, videos typically work better in the other mode, the landscape mode, not portrait mode. All right, one last tidbit I wanted to share here. Doing matrices by hand, like, although I'm a nerd and it's kind of fun when you are learning them, getting them in reduced row echelon form and manipulating all, uh, getting the zeros and ones, like binary, like you need in order to get that end result that's given here. I wanted to show this other website, and all I did is I Googled a matrix solver, and I think it was the first one that showed up. But then when I tried to just take the website, it was in Russian. So Google this, and it started with matrixcalc.org. Matrixcalc.org. Okay. So when you Google that, find this one. It was the first one for me that popped up. I loved it. It was great. I don't know, kind of on some levels more friendly than the GeoGebra site. But what else I love about this is it shows you, if you were trying to do any of these by hand, this entire process. The process is called Gauss-Jordan elimination in order to get a matrix in reduced row echelon form. Okay, and they tell you what computations they did at each step and highlighted them in blue. Pretty cool. All we had to do was tell it, what is our system of equations? So on the left, there were some different options for matrices. I chose the systems and I put it in like this. And then you tell it what you want it to do. You could add cells using those buttons there, right? But I took exactly what we put in GeoGebra and just input it in the system there and then played around with it. It's a pretty cool site. Got the same results, 1640, 10360, and so forth. Cool. I know it's a lot, but technology is our friend, right? Look at all those steps. I didn't do this matrix by hand. I did in another video. I don't think it was as large as this one, but I really hope this helps you out. Again, that was a kind of a tricky question because it does have that infinitely many solutions, and I did want to show what it looks like, but then how when we add information, we could continue solving it. Great.